negative and positive, adding up, giving you 0. So hence you can't really calculate the distance from the mean. So what you do instead is, okay, so in the CFA syllabus, we come across a concept of dispersion. So what we need to understand dispersion is by understanding what exactly it means and what exactly are we trying to calculate, what are the weaknesses and what are the strengths of this calculation, right? So I've taken two systems out here. One is CTA, which is basically is a short term for managed futures. These are basically dealing with different future instruments. And we are looking at long short equity, which is purely using leverage to be net neutral in the market, right? So I have got this data here for about somewhere around 263 months. So the sample size is pretty big. And now what we are trying to look out here is the various monthly returns that we see out here, right? So we can see various monthly returns out here. And now in order to understand dispersion, right, we have to understand that what exactly we try to do. So what we do is first let's try to take a mean, a sample mean of all of the monthly returns, right? So that would be just taking an average, okay? So I took the average and that comes out to be as 0.41. Now in each of these entry, what I'm trying to find out is how far is it from 0.41, right? So let's try to just first directly do 0.41, right? Now you might ask that, okay, if I do this for all the entries, right? And then I say, okay, what is the total of this? This total would actually come as 0, right? Because finally minus and positive would cancel each other and then the total would be 0. So that really does not calculate the actual deviation from the mean, right? And you can see out here, there are some places where it is negative, there are some places where it is positive, right? So negative and positive, adding up, giving you 0. So hence you can't really calculate the distance from the mean. So what you do instead is, in order to make this positive, there are two methods, right? One is that I ignore the signatures, the signs, right? So I take the negative also as positive and I take the positive as positive and then calculate the deviation. That would actually come as a different concept, also called as the mean absolute deviation, right? So, but in case of, if I don't want to calculate, ignore the signs, then what I could do instead is square this up. So if I square these distances from the mean, they would invariably become positive, right? So you can see here, now it has become positive, right? So now let me just drag that across. And now you see down, if I look at the sum out here, below in the calculation, you can see that the sum actually does not come to 0. It comes to be 14.27, right? Now that's something that you need to remember, that we squared the deviations from the mean, right? Squared the distances from the mean. Now let's come back out here and let's take that value of sum of squared deviation from the mean, okay? Yeah. So we'll take the total of that, which we briefly saw below, and which comes to be 14.27, right? Now, when I've taken as a sum of squared deviation, right, it really is not telling me that on an average, right, how much does my returns of my fund fluctuate from the mean, right? So what I will do instead is, now since I've taken so many observations, just like how I calculate a mean, I take the sum and I divide it by the number of observation. So I can use a count a function, although in the CFA syllabus, you would not have the luxury of having this function, but nevertheless, you need to get the idea. So now what I get is 0.05 as the average square distances from the mean, right? Because I've taken the average, because 14.27 was the total of it, right? Now, if I want to remove the effect of the square, right? Because initially I said that you need to remember that we squared the distances from the mean, right? So if we have to remove the effect of squared, then what we will do instead is take a square root. Okay, this is the reason why we actually put the square root at the first place. Okay, so there you go. So I've taken the square root, right? And now what I'm getting is on average monthly deviation from the mean and this is monthly. Now you might say that, okay, this is telling me the monthly fluctuation, but what about the annual fluctuations? So annual fluctuations is nothing but, again, since we're always dealing with a squaring, right, from the first place itself, so I will take a square root of 12 months. Since this is about monthly returns, so if I want to annualize it, I will just take a square root of 12, and that would give me the standard deviation of 8.07, right? Now, how does this help? So if I take again the standard deviation of, let's say, a long short fund, so the long short fund is this, right? And you could see that that would come as a monthly standard deviation of 1.99. And if I take a square root of that, right? So if I take a square root of 12, that comes as 6.91. Now, another aspect what you need to understand is that, so basically what you're trying to say is long short equity fund is probably less volatile than CTA Global, right? But you need to understand that we are relying on mean returns, and mean returns will most likely try to ignore the outliers, and that's what is the main issue with dispersion. And that probably what we'll discuss is when we come up with some other concepts of dispersion, is when we will discuss how there are better versions of trying to find out which of these funds are actually more riskier or less risky.